We have a cubic polynomial here with an unknown, this k, as a parameter, and it's denoted by f of x, and we're told that 2x minus 1 is a factor. So first things first, use the factor theorem to show that k is equal to minus 37. By factor theorem, and because 2x minus 1 is a factor, it must be that f of a half is equal to 0. It's essentially the value of x that I'd get if I solved 2x minus 1 equal to 0. It's easier when you have things like x minus 3 because it's just f of 3 is 0. But in this case, it's f of a half is equal to 0. And now we can substitute that in to my f of x. So it must be that 6 a half cubed plus k a half squared plus 57 times a half minus 20 equals 0. And we can use our calculator to help us out here. So I'm going to get, well, I'm going to do some of it in my head. So a half cubed is actually 1 over 8. So it's going to be 6 over 8. This one I'll leave for the moment. Then I'm going to be adding 57 divided by 2. That's the same as 57 times a half. And minus 20. So I get 37 over 4. Meanwhile, a half squared is a quarter, so it's k over 4 is equal to 0. I can times through by 4. 37 plus k equals 0. And this gives us that k is equal to minus 37. Okay, so that's that first bit sorted. Using this value of k, factorize completely, and we're being asked to show detailed reasoning. It's always good practice anyway to show it fully. We're going to use a polynomial. I'm going to use polynomial division for this. There's more than one method. There's inspection and so on, but polynomial division is just a good method that will always work, and it will work when you're dividing by harder polynomials. So it's good to master. All right, we're going to divide our polynomial, or we know what k is now. There we go, that's the division we want to do. So 2x into 6x cubed is going to become 3x squared. Multiply back through. Subtract. Just be careful with the negatives, bring down the next one. 2x into minus 34x squared is going to become minus 17x. Multiply the minus 1 by minus 17x and subtract. Plus 20, because 2x into 40x goes 20 times back through. We know, well, we're expecting to get 0, so if we don't get 0, we know we made a mistake, but we'll get 0 here, so it's all good. Therefore, f of x equals this factor we just divided by, and the quotient, what we are left with. We're being asked to factorize fully, and so I just need to also factorize this quadratic now. There are ways of just getting your calculator to do it for you using quadratic formula and kind of working backwards, but I strongly recommend just learning to factorize. Just keep practicing it, because it is actually quicker once you do. I'm expecting this to factorize. Of course, it might not, but it's a good skill to have. Right, so I'm going to try and find two numbers that multiply to give 20, and when I do a combination, they're going to get me minus 17x. Now I know they're got to both be negative, therefore, because there's a minus 17x. So I could try 4 and 5, and if I just sort of look at it, I can see that if I put 4 here, I'll get 12x. And if I put 5 here, I'll get 5x, and that will indeed work. I just need to make them both negative, because that will then make both of these negative, and I'll get my 17x. So it's not, doesn't take too long. If I, of course I could get it the wrong way around, but always like go for some numbers that are kind of similar, I suppose, because this is not a very large number in comparison with the two numbers that multiply to give 20. All right, and that's my final answer. Okay, last part. We've now got this exponential equation, which we've sort of been guided towards solving. Okay, hence find the three values of t that satisfy this equation. And this is very similar to what we have. It's just we had x cubed, and now we've got e to the minus 3t. Now that can actually be written as e to the minus t cubed. So it is in fact a hidden cubic in terms of e to the minus t. Let's x equal e to the minus t. This implies x squared. Now it's going to be e to the minus t all squared, which you can then bring in to write e to the minus 2t. And similar for this one. So we can see that we're going to get that factorized form from before equal to 0. I've just kind of replaced all these by x cubed, x squared, x, and I've used my knowledge from above, the fact that we can factorize it into these linear factors. So x is going to equal a half when I set this first bracket equal to 0, 5 over 3 when I set the second bracket equal to 0, or 4. And remember, now we bring back the t. E to the minus t is equal to these things, because that's what we're actually solving for. But we want what t is, so we need to undo the logs. And that's going to mean that minus t is equal to ln a half. There's two ways to think about it. Either, if you remember what ln is doing, it is the base, which is e, to the power of this thing, minus t, is equal to a half. They're the same thing. So you can just swap between these two if you understand the connection. You could also consider finding ln of both sides. And if you find ln of e to the minus t, you can bring the minus t down. You can find ln of e, which is just 1, and you'll again get minus t equals ln of a half, whichever you prefer, but make sure you can do this. You get ln 5 over 3 or ln 4. And that's going to mean that t is equal to minus ln a half minus ln 5 over 3 or minus ln 4. And that would be a completely valid answer. I'm going to go one step further because it is good to, it's actually not very neat to have a fractional log with a negative outside, because you can do the following. Minus ln x is actually equal to ln x to the minus 1, because I've used my third rule of logs to bring it up, which is ln 1 over x. And in the same way, minus ln a over b, if you bring up the minus and you do a over b to the minus 1, you take the reciprocal of a over b, it just becomes b over a. You can simply get rid of the negative and swap them around. So t is actually ln 2 ln 3 over 5 or ln 1/4. And for me, that is a much simpler answer. We're then asked to find the sum of the three values as a single logarithm. So it's going to become ln 2, and again, this is going to be easier without the minuses, plus ln 3 over 5, you can still do it there, of course, plus ln 1/4. Right, now I've got one other tool I need to use, and it's the fact that when I add logarithms, so ln A plus ln B, it's the same as if I find ln of these two multiplied together. And that will work for these three together, so it's going to be ln 2 times 3 over 5 times a quarter. Let's take it step by step. So it's going to become ln 2 times 3 over 20. And 2 times 3 over 20 is just going to become ln 3 over 10, because I times the top by 2, which then cancels partially with the 20, or I can just imagine just cancelling like that. So this is my final answer. Quite a lot involved in this question, but I hope you're happy with it.